morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today in this video, I am going to present you the solution of October-November 2024. Paper 2, the zone of the paper is 2, you can say the variant. 2, the time allowed for this paper is 1 hour and 45 minutes. In this video, the paper and the marking scheme which we are using, that marking scheme and the paper is the property of the Cambridge Assessment International Education. I have downloaded these papers, these marking schemes from their website, and they are the property of the CAIE. I am just using them. This paper is not created, the marking scheme has not been created by me. This is the property, the intellectual property of the Cambridge Assessment International Education. So let's start today's paper, October-November 2024 2-2 paper. So in this paper, the value of the G will be taken as 9.8 instead of 10, which we were used to take in the previous papers. So here we have question number 1 showing up on your screen. It says, a jet ski is a type of boat that carries 1 or 2 people and travels at high speed on water. Figure 1.1 shows a student riding on a jet ski. So here you can see that we have that jet ski. The jet of the water is coming in this way, and the direction of the movement is to the left. A high-speed jet of water is forced backwards out of the back of the jet ski by a pump inside the jet ski. The pump increases the momentum of the water that is forced backwards out of the back of the jet ski. Complete the word equation to show the relationship between the resultant force on an object and the change in the momentum of the object. You know, the resultant force is equal to the rate of change of momentum. That means change of the momentum divided by time. So I think, let me show you, the solution has been written by one of my students. Her name is Hajra, thanks to her. And the solution was written under my supervision. So here we go. They say the change in the momentum divided by time. Change in the momentum divided by time. Okay. So you have look at the marking scheme. Then they say in 2 seconds, the pump increases the backward speed of 80 kg of the water by 30 meters per second. Calculate the backward force exerted on the water. The initial velocity of the water is 0. The final velocity of the water is 30 meters per second. The mass of the water is 180 kg. And the time taken for this change of the velocity is 2 seconds. So we can find the force. That force will be the change in the momentum divided by time. That will be mv minus mu, the whole thing divided by the time. So here we go. So mv minus mu, the whole thing divided by t. So the mass I can take common. And so that mass is 180 kg, bracket, and the final, the final velocity is 30. She has made a mistake here. So let me take the pen and write here. So here the final velocity must be 30 and the initial velocity is 0. Okay, so the final velocity is 30 and the initial velocity is 0. So 30 minus 0 and divided by, because it took 2 seconds. So it will be 180 into 30 and that will divided by 2. So that will be 2700. 2700 is the answer. Let's check the answer. So it's 2700 Newton. So the final velocity of the water is 30 minus the initial velocity is 0 and the whole thing divided by 2. So 180 multiplied 30 and then divided by 2, that will give you 2700 Newton. I hope you understand. I hope you understand this mistake she made. Okay, so let's go to the next part. And in the next part, you see he says question number 1 is B part, and they say Using Newton's third law of motion, explain why there is a forward force on the jet ski. You see the pump is applying force on the water, and the water will apply the force on the pump. And both these forces, they are the action and reaction. So the force which will be exerted on the water, the same amount of force will be exerted on the pump, and the water will go to the right, but the pump or the jet ski will go to the left. So they are action and reaction. They both are equal in magnitude, opposite in direction. So these are the Newton's pair of forces. So let me see what she has written. Okay, so you can see that the pump exerts a backward force on the water. The water exerts an equal and opposite force on the pump. So these are the Newton's pair of forces. So let's see what the marking scheme says. Marking says pump or jet ski engine exerts force on water. Water exerts an opposite force on the pump or the jet ski engine. So this is her answer, and this you have seen the marking scheme. I hope you can write a good answer right now. Okay, the question number 1B, second part. The student has a mass of 70 kg and the jet ski has a mass of 280 kg. Use your answer from the A second part to determine the acceleration of the student and the jet ski when no resistive forces are acting. We know the force and we can find out uh, acceleration. You know Newton's second law of motion, F is equals to ma. F is equals to ma, where F is the resultant force and the m is the mass. And very easily we can find the A value. F is equals to ma, the equation we are going to use. And here we go. F is equals to ma, so 2700 is that Newton, is that resultant force, equals to the mass is 280 plus 70, and the acceleration is the question. So 2700 divided by 350, and that will be 7.7 meter per second square. 7.7 meter per second square is the right answer, sir. So this is the solution. Question number 1, and it's C part. He says the jet ski reaches a speed of 20 meter per second. Calculate the total kinetic energy of the student and jet ski at this speed. You know, the kinetic energy, the formula for the kinetic energy is 1 by 2 mv square. 1 by 2 mv square is the formula. So we will apply that formula 1 by 2 mv square. So 1 by 2 into the 350 into the 20 square. So that will be 70,000. 70,000 joules. 70,000 joules is the answer, sir. You can see we have used this formula 1 by 2 mv square, and we have found the kinetic energy, that is 70,000 joules. Very easy peasy. Okay, so on your screen, the question number 2 is showing up. He says, a glass beaker of mass m is at rest on a horizontal surface. The base of the beaker is a circle with a radius r. The beaker exerts a pressure on the horizontal surface. Determine an expression for the pressure in terms of the gravitational field G, M, and R. Okay. So we have to find out the pressure in terms of G, M, and R. Because the base of the beaker is in the form of a circle, so its area is pi r square, and the weight of the beaker is mg. Pressure is force divided by the contact area, so the pressure will be weight divided by contact area. So it will be mg divided by pi r square. It's a 2 marks question. So let me show you. So the pressure is equals to force divided by area. That will be equals to mg divided by pi r square. So it will be mg divided by pi r square. So here we go. Okay. So then we have figure 2.1 shows the beaker being filled with a liquid from the container X. Okay. So from this container X, the liquid is being poured through this tap into this beaker, and this is the horizontal surface. Initially, the beaker is empty. Okay. So then he says at the time t equals to 0, the tap is opened and the liquid from the container X flows slowly into the beaker at a constant rate. At the time t equals to capital T, the liquid stops flowing into the beaker. Okay. Then sketch on the figure 2.2 to show how the pressure exerted on the horizontal surface varies between t0 to t equals to 2t. As the time will pass by, the mass of that water in that beaker that will increase. And as the mass of the water in that beaker will increase, you know, the pressure on the table surface will also increase. So I think they are kind of directly proportional. But when there is no water, still there will be some pressure due to the weight of the beaker. The weight of the empty beaker, there will be some pressure. So we will draw a graph, and you see from here, this graph will start, and you can see this is a straight line. And after the T, you stop that tap, and then obviously no more water is coming into that beaker, so the pressure will become constant. So you can look at here, straight line with the greater than 0, horizontal line at the end of the initial line. So you can read the story again. You see what does the story says? At t equals to t, the liquid stops flowing into the beaker, okay? So at t equals to 0, we open that tap so that water started collecting here. So the pressure on this table will increase gradually. But at t equals to t, we close this tap. So no more water is coming. And so whatever is the water in this beaker will remain. It will become constant. So the pressure on the table will also become constant. So I hope you understand this story. Okay, so the next thing is question number 3 showing up on your screen. He says the figure 3.1 shows a laboratory freezer, copper. Here we have copper pipes. Here we have thick insulation. The door is opened and the door is closed and the freezer is switched on. The cold liquid is pumped through the copper pipes at the top of the freezer. The temperature of the air next to the copper pipe decreases quickly. Explain how the temperature of the rest of the air in the freezer decreases. It's a three marks question. So the air which is here near the copper pipes, the copper pipe, inside those copper pipes, we have a very cold liquid. So the air on the top here, that will get, its heat will be absorbed by those copper pipes, and that air will become cold. When the temperature of that air will drop, the cold air, its particle will come close to each other. That air will become dense. So that dense air will go downwards, and the air which is here, which is relatively at a hotter temperature, that being less dense will rise up. So here the cold air will go down and the hot air will rise up. And in this way, the convection currents will be created inside this freezer. And by the convection currents, what will happen? The temperature of that whole compartment, the air in that compartment, that will decrease. So let's see what Hajra has written, and let's see if he has written properly. Okay, the air near the pipes contract, its density increases. This colder, denser air sinks, warmer and less denser air rises, and convection currents are set up. So it's a 3 marks question. Let's check what the marking scheme says. The marking scheme says It says that air next to the pipe contracts, its volume decreases and its density increases. 1 mark for this. And cold air or air next to the pipe sinks, that cold air goes down, and warmer air at the bottom of the freezing compartment rises or convection current set up. Okay, so these are the 3 marks for this part, and this is my student's answer. I think this answer is good. So you can also write your own answer. Okay, so question number 3, and it's B part. The thick insulation shown in the figure 3.1 is made from a plastic material. The plastic material in the insulation is a poor thermal conductor. Describe how thermal energy is transferred through a plastic material. You see, the plastic material does not have free electrons. So it's a solid. So how do the thermal energy will transfer through the plastic? Because the plastic has particles which are close to each other. So the particles which will be at a hotter end, they will absorb the thermal energy and they will start vibrating vigorously. The amplitude of their vibration will increase. So because of larger amplitude of vibration, they will collide with their neighboring atoms or molecules, and they will make them vibrate vigorously, and they will make their neighbors vibrate vigorously because their amplitude of vibration will increase. And in this way, from the hotter end, the energy through the vibration of the particles is transferred to the colder end. So this is a 2 marks question. So let's see what Hajra has written. So let me, okay. So here we go. So atoms, particles at the hot end vibrate vigorously, made their neighboring particles vibrate too. Energy is transferred by the vibration. Amplitude of vibration increases. So they collide with their neighboring particles. Write this sentence as well because we have still 1 line. So you can write this answer as well. The marking scheme says it has 2 marks, 1 mark for saying that the particles vibrate and collide with other particles. And the second number is for saying that the collision transfer thermal energy vibrate or thermal energy vibration pass to neighboring particles, neighbors, and nearby particles. So this is Hajra's, my concern is only that also write the vibration. The amplitude of the vibration will increase. Okay, so question number 3B, it's the second part. He says the plastic material also contains a large number of small air bubbles. Explain how the air bubbles reduce the transfer of thermal energy through the insulation. Usually, the air which is trapped in those air bubbles, the air is a bad conductor of the heat. The air is a bad conductor of the heat. So what will happen? They will not conduct, or at least they will reduce the conduction of the heat because the air trapped in those bubbles is very bad conductor. And because because that the heat is supposed to be transferred by the vibration of the particles, and because the air is loosely, the distance between the particles is larger, so they do not transfer the vibrations to the next particle. So Aja says that air is a bad conductor of heat, so conduction is reduced. Air bubbles also do not, another thing, the air bubbles do not, because they are trapped, so they will not be able to do the convection. They do not transfer energy by vibrations to the next particles in the solid form. These are 3 marks question. 1 mark is for saying that air is trapped. Trapping the air, the bubbles, they reduce or prevents convection. And the third number is for saying that air is a bad conduction. So you see, when the air is trapped inside a bubble, so what happens? The air is a bad conductor, so no conduction will happen. And the air is trapped, so no convection currents can be created in that air. Okay, so next question is question number 4 coming up on your screen. He says, figure 4.1 shows a large syringe that is sealed at the nozzle by wax. There is a piston inside the syringe. The pressure of the air inside the syringe is equal to the atmospheric pressure, 1 expo 5 Pascal. The volume of the air inside the syringe is 1.2 expo minus 4 meter cube. The area of the end of the piston that is in contact with the air is 3.5 expo minus 3 meters square. The friction between the piston and the syringe is negligible. A first part is calculate the force on the piston due to the pressure of the air inside the syringe. You know the pressure is force divided by area, so the force will be equals to uh, pressure multiply area. Pressure times area. Let me show you. So the pressure is equals to force divided by area. So the force will be equals to the pressure is 1 expo 5 Pascal, and the area of the piston is 3.5 expo minus. So if you multiply them, you will get 350 Newton. 350 Newton is the right answer, sir. So you can look at the marking scheme. 350 Newton is the right answer, sir. This is how this is done. Okay, so the next part is a second part is the force on the piston in the A first part acts to the right. Explain why the piston does not move to the right. You know, the inside pressure, you have said that this is equals to the atmospheric pressure. Outside also the atmospheric pressure is being exerted. So the force inward and the force outward, they both are equal to each other, because inside and outside the pressures are same. So that's why the forces will be balanced and the piston will not move. Force acts on the piston to the left due to the atmospheric pressure, and the pressure inside and outside the syringe is equal. The forces are balanced and no resultant force acts on the piston. So that's why the piston will not move. Okay, it says force to the left or force due to the atmospheric pressure, pressure of the air surrounding the syringe. 1 mark for this. No resultant force on the piston. The two forces are balanced or forces in equilibrium. Okay, so this is how this is done. So B part, the piston is now pulled to the right by an additional force. The temperature of the air in the syringe does not change. Explain in the terms of the molecule particles why the pressure of the air in the syringe decreases. You see, if you will move this piston to the right, so what will happen? The air which will be trapped here, its volume will increase. And you are saying that the temperature has not changed. So now what is happening? There is gas in that cylinder, and you have increased the volume of the gas, and you are saying that the temperature of the gas has not changed, of the air, I mean. And what will happen? Now, you know that the pressure and the volume, they are inversely proportional to each other if the temperature of the gas is constant. You remember that P1, V1 equals to P2, V2. That famous equation, the pressure and the volume are inversely proportional to each other if the temperature of the gas is constant. So what will happen? What will happen? The pressure of the gas will decrease, because now you see the collision frequency of the air particles who are colliding with the piston and the sides of the cylinder, that collision frequency of the air particles colliding with the walls of the piston and the cylinder, that will decrease. So now, due to that decrease in the frequency of the collision, what will happen? The force which will be exerted per unit area, that will decrease. The particles have to move a larger distance to collide with the walls of that container. So let's see what my student writes. Okay, so the volume of air increases. So the particles of the gas are further apart. There are lesser particles of gas per unit volume. Oh, this word is also very important. Remember this word, because now the volume of the air has increased, so the number of the particles per unit volume has decreased. This is a very important sentence. the number of particles of the gas per unit volume has decreased. Their collision frequency of air particles with the walls of the syringe has also decreased. That's why a less force per unit area will be exerted, and that's why the pressure of the gas will decrease. So we think this is the answer. So there are 3 marks for this question. Question number 4, B part, its first portion. The particles, they hit the wall, side, piston, and the string. Particles, they less densely packed, more spread out further apart. Collision of the particles less frequent. Okay. So this is the answer. These are the 3 marks, and this is the answer written by my student. And now we are going to the second part. Calculate the pressure of the air inside the syringe when the volume of the air is 1.5 expo minus 4 meter cube. So we will apply that formula P1 V1 equals to P2 V2. This formula is applied whenever the temperature of the gas is constant and you have changed the volume, and the pressure obviously will change. Pressure and volume are inversely proportional. P1 V1 equals to P2 P2, because when two quantities are inversely proportional to each other, their product remains constant. So P1 is 1 expo 5 and the V1 is 1.2 expo minus 4 equal P2 is the question. V2 is 1.5 expo minus 4. So just bring this 1.5 expo minus 4 to the left and it will divide there. So then do this calculation. So you will get 80,000 Pascal. 80,000 Pascal. Is this the answer? Let's check. Yes, sir. 80,000 Pascal is the answer. So 8 expo 4 Pascal is the answer. This is how my student has done this. And let's go to the next question. The next question is question number 5 coming up on your screen. It says some glass lenses are converging lenses and others are diverging lenses. Draw the cross section of a diverging lens. Diverging lens is the concave lens. So they diverge the light. So in the middle, they are thin, and on the ends, they are thick. So it's a 1-mark question. Let me show you this diagram. So, okay, so here we go. This is a concave lens. This is diverging lens. In the center, it is thin, and on the ends, it is thick. So this is a diverging lens. Draw a lens that is thinner in the middle than at the edges. Okay, so that was question number 5, A part. And then we have question number 5, it's a B part. And here we have, so let me reduce the size. Okay, he says figure 5.1 shows the cross section of a converging lens. The principal axis and the two principal focuses, focal points F1 and F2 on a full scale grid. Okay, so here you can see the focal length is 1.8 and 1.8 is the optical center. Okay, so what is their question? So their question is, he says a student places an object of height 2.1 centimeter at a distance of 3 centimeter from the center of the lens. Using the figure 5.1, determine the focal length of the lens. The focal length here is clearly, this is from the optical center, this is 1 centimeter, 0.2, 0.4, 0.6, 0.8. So this is 1.8. So the focal length is somewhat 1.8 centimeter. The focal length is 1.8 centimeter. So you can see that our answer is right. Okay, then their question is, on the figure 5.1, draw a vertical arrow of the height 2.1 centimeter, that is 3 centimeter from the center of the lens, and label the arrow O. The arrow is the object. Okay. On the figure 5.1, draw 2 rays from the tip of the object arrow to find the tip of the image. Draw another arrow to show the image. Okay. So let me show you. Okay, so here we go. So at a distance of 3 centimeter from the optical center here, we have drawn an arrow. Its height is 2.1, and so that is one part. Then we have to start two rays from the head of this object. One ray will go parallel to the principal axis, and then from here it will bend and pass through this principal focus. And one ray will start from the head of this object, and it will go from the optical center. When it goes from the optical center, its direction do not change. So where these two rays intersect each other here, the head of the image will be formed. So here is the image which will be formed. I hope that you understand this. So their question is, on the figure 5 point draw, okay, we are done with this. Using the image marked on the figure 5.1 in the B's third part, determine the linear magnification produced. You know the linear magnification, there are two formulae for the magnification. The linear magnification is the height of the image divided by the height of the object. Height of the image divided by the height of the object. And another formula is the distance of the image from the lens divided by the distance of the object from the lens. So you can find out so you can say this height of the object is 2.1 and the height of the image here is, I think, 2. It's almost like maybe 2.9 or maybe 3. So you can take it 2.8, 2.9. So the linear magnification will be, sorry, it's 3.8. Let me check. Oh yeah, 1, 2. Oh, it looks like 2.8 to me. So this is 1, 1, 2, 3, 1, 2, 4. So to me, it's look like 2.8. Why she has written 3.8? I am still looking for this. Okay, another way of finding is 1, 2, 3. And this will be 4. This is 4.1. So what I can do, let me calculate on the calculator. We can find out this. So I think it's 2.8, but she has written there 3.8. I don't know why she wrote 3.8. So I think she has made a mistake and she wrote there. Okay, so let me check again. I think this is 1, 2. It's like 2.8, yeah. So if you will divide 2.8 with this height is 2.1. So if you divide 2.8 with 2.1, what will be the answer? You will get, you have to check. So, but she wrote 3.8 divided by 2.1, and that is 1.8. So let me get my calculator and let's see what is that. So we have, I have checked it again and again, and the technique is right, but you see here she has made a little mistake. The line should have been started from here, 2.1, and then it should have gone very parallel to the principal axis. And you see, it should have passed from the center of this F, and she is little off from here, she is little off from here. And that's why the point of intersections are not at 3.8. But she has used the value 3.8 divided by 2.1, and that gives you 1.8. If you draw it very accurately, if you will draw this diagram very accurately, you will get the right numbers. So unfortunately, our numbers, when I count from here, that's approximately 3. It's not 3.8, but when you will draw them very accurately, it will come 3.8. And when you will divide it with the height of the image divided by the height of the object, you will get 2.1. So see, there's no problem. Simply, you have to draw this diagram very accurately. Your pencil should be sharp. It should be passing through the center of the F2, and it should be the other line should be passing from the center of the optical center. And obviously, you will get the right answer, sir. Magnification you can find by two things: the distance of the image from the optical center divided by the distance of the object from the optical center, or height of the image divided by the height of the object. I can show you the marking scheme. In the marking scheme, the answer is 1.8. It says it can be from 1.2 to 1.8. Even if you divide, let me use calculator. And when you divide one, yeah. So here we have done, where is the, if you take those right values, 4.2, these are the values which she used. 4.2 divided by 3, the distance of the image divided by the distance of the, you get 1.4. That is in that range. And if I use that value which she has used, I can use the exact values. 3 divided by the actual height of the image, which is in that diagram, is 3. If you divide 3 with the 2.1, you get 1.4. You get 1.4, 1.4, 1.4, which is in this range. So there is no problem with this. I don't know why she used 3.8, and the 3.8 should have not been used. Okay, so let's move to the next part. The next part says draw. We are done with this magnification thing. Okay, the last part, the fifth part, explain whether the image of the object is real or virtual. This image you can see is enlarged. This image is inverted. And this is on the other side of the lens where the object is. This is on the other side. So it is found by actual intersection of the lines, the rays. That's why it's a real image. This is a real image. Rays actually meet and formed screen. It can be formed on a screen also. So it's a real image, real and formed by converging light rays. Actual rays has converged and intersected with each other. I hope you understand this. The values which she has taken. Once again, let me explain you the fourth point. The height of the image divided by the height of the object. The height of the image here is approximately 3, or you can say 2.8. Even if you take 2.8, let's see what the answer comes. If I divide 2.8 with the 2.1, I get 1.33. I get 1.33, and it is in that range which the answer says in the marking scheme. So there is no problem with this. Only problem is she used the digit 3.8. I don't know from where she got that. Okay, so we have the next question coming up on your screen. That is question number 6. Figure 6.1 shows the circuit symbol for a relay and 2 labeled terminals. By referring to the figure 6.1, explain the effect of the current passing explain the effect of a current passing from A to B. You see, when the current will flow from A to B, this coil here, this will become magnetized. It will become a magnet. It will start behaving like a bar magnet. It will be an electromagnet. So what will happen? That will attract this toggle, this relay switch, and this relay switch will move to it will be attracted to that magnet, and it will come to the left, and here that switch will be closed, and the circuit here will be completed. This second circuit will be completed when a small amount of current will be introduced from A to B. So let's see what my student writes. And okay. So magnetizing coil provides magnetic field and becomes an electromagnet. It attracts the toggle of relay switch and the switch closes. So this toggle will be attracted to the left with this magnet, this electromagnet, and here the switch will be closed. So let's check. It's question number 6, and it's A part. Current in the AB, the magnetizing coil produces magnetic field. The relay switch between X and Y closes, or switch attracted by a magnetic field coil or relay switch made of iron. Yeah, the toggle is made of iron. Okay, question number 6, and it's B part. He says the figure 6.2 shows two circuits linked by a relay. The heater transfers energy at a rate of 40 watt when it is connected to a 12-volt supply. Switch S is closed. The variable resistor is adjusted so that its resistance R increases from 0. Okay, what is the question? Figure 6.3 shows how the power transferred in the 60-watt heater varies as the R increases from 0. The graph shows a sharp decrease when the resistance R reaches RH. Explain the shape of the graph. You see, when you are increasing the resistance of that variable resistor, so at a certain, so so it will allow the current to flow through. Let me show from. So basically, what is happening? You are increasing the resistance of this variable resistor. So as the resistance of this variable resistance will increase, so this circuit is the resistance will increase. So the amount of current coming from the battery will gradually decrease. So, so the strength of this magnet, the magnetic electromagnet, which is formed on that coil, that depends upon the amount of current flowing through it. So if the amount of the current will decrease, the electromagnet here will become weaker. So at some point, what will happen? The amount of current because of the high resistance will decrease. It will become so low, the amount of current will become so low that the strength of this magnet will be very weak. So what will happen? It will be no more able to attract this relay switch. So this relay switch will open, and all of the sudden, the current flowing through this circuit will stop. I hope you understand what I am saying. Let me see. So the power being provided will be all of a sudden become 0. So initially the high current from through relay coil and relay switch is closed, heater is on. As the resistance of the resistor increases, that variable resistor increases, current and the magnetic field of circuit decreases, and the relay switch opens at the RH, so no current flows through the heater. I hope you understand. So let's see what the marking scheme has to say. Initially, the current in the relay or coil is large, or relay switch in the relay circuit relay is closed, or heater is connected to a 12-volt supply, or voltage of the supply does not change, or heater is switched on. As the R increases, the current magnetic field in the relay coil decreases at R equals to RH. Relay switch in relay coil opens, or magnetic field not strong enough to hold the switch closed. I hope you have understood, and if you need thing, I can tell you once again. At the start, the resistance of this variable resistor is 0, so the maximum current is coming and passing through this coil. This coil will become a strong magnet. It will attract this switch, and this switch will be closed. Heater will be on. The power will be supplied to this heater. But as you will increase the resistance of this variable resistor, the amount of current coming from this battery passing through this coil will decrease. So as the amount of current passing through this coil will decrease, this will become a weaker electromagnet. So then when it will become a weaker electromagnet, it will be no more able to attract this switch, and this switch will open, and then no more power will be provided to this heater. I hope you understand. Okay. He says the 40 watt heater connected to a 12-volt supply is switched on. Calculate the energy transferred in the heater in 2 minutes. You know the energy is equals to power multiplied time, or you can say it's also equals to energy equals to IVT. So we can use any formula here. So energy is equals to power multiplied time. So the power is 40 watt. The time is 2 minutes, but the time should be taken in seconds. So 2 into 60 to convert the 2 minutes into seconds, because in 1 minute there are 60 seconds. So if 40 into 2 into 60, that will be 4,800 joules. So the energy transferred is 4,800 joules. 4,800 joule, question number 6C, first part, 4,800 joules is the answer, sir. Okay, then their question is the resistance of the heater is the question. We know the, we know the power, we know the voltage, we can calculate the resistance. And the power is equals to V square by R, and power is 40, voltage is 12, so square divided by R. R will be equals to 144 divided by 40, and that will be 3.6. 3.6. Here you can use other formulas also. You know the power, you know the voltage, you can find the current, then you can use V equals to IR. But this is a direct formula. Power is equals to V square divided by R. Okay, I'm hopeful that you understand this. So here we have question number 7. It says the frequency of an alternating current means electricity supply is 50 hertz. The maximum voltage of the supply is 300 volt. And using the axis in the figure 7.1, sketch a graph to show how the voltage of supply varies in a time of 0.05 seconds. Okay. So the frequency is given. From there, I can find out the time period. You know, the time period is equals to 1 by F. The time period is equals to 1 by F. The frequency is 50 hertz. So the time period will be equals to 1 divided by 50, and that will be 0.02 seconds. So in 0.02 seconds is the time period. So in 0.02 seconds, one wave will be completed. In the next 0.02 seconds, the second wave will be completed. So at 0.01, half wave will be done. The maximum voltage is 300. So because it's alternating current, it will go into negative, into positive, into negative. So I will put dot here, I'll put a dot here, I'll put a dot here, I will put a dot here, I will put a dot here. So there are 7 points, okay? So the wave will be like this. In 0.02 seconds, the wave is completed. The time period is 0.02 seconds. How we found that? We know the frequency. So 1 divided by F, that will give you the time period. So this is how you will sketch this. A sinusoidal, the shape is called sinusoidal. Curved line drawn on the figure 7.1, at least one sinusoidal cycle of period 0.020 seconds on the figure 7.1, 2.5 sinusoidal cycles of the period 0.020 seconds, and an amplitude of 300 volt on at least one cycle on the figure 7.1. So our answer is right. This is how you will draw this. Okay. We're done with this. Okay. Question number 7, and it's B part. He says the figure 7.2 shows the mains power supply connected to the primary coil of a transformer. The primary coil consists of 750 turns. Okay, so on this primary coil where you have supplied with the main supply, so this primary coil has 750 turns. The core of the transformer is made from the iron. Explain why iron is a suitable material for the core of the transformer. You see what will happen. The iron is a magnetic material, so it will concentrate all the magnetic lines which of this electromagnet, and this iron core will provide a path for them. So all of the magnetic lines will be concentrated in this core, and then they will pass through this secondary coil, and then from here they will come back. So no magnetic lines will go out into the air, so the magnetic field will be the not wasted, you can say. It will provide path for the magnetic lines to, to go through the secondary coil. Okay. It's a soft magnetic material, magnetizes and demagnetizes. These provide the path for the electromagnetic flux to pass from the primary coil through the secondary coil. So it's a temporary magnetic, and another very good thing about the magnetic iron is that it's a soft magnetic material. When you provide it with the magnetic flux, it converts into magnet, and when you switch off that magnetic flux, it demagnetizes immediately. It's a soft magnetic material. Okay, then he says, explain why there is voltage across the secondary coil. You see, try to understand, this is a very important part. You see this primary coil, you are providing it with an alternating current. So on this primary coil, magnetic field is created, a magnet is created, electromagnet is formed here. And the polarity of that electromagnet and the magnetic strength of that electromagnet is periodically changing. Sometimes this becomes north, and sometimes this top side becomes north. So the electromagnet, which is formed on the primary coil due to this alternating current in the primary coil, is periodically changing its polarity, and it is also changing its magnetic flux, its magnetic strength. So its magnetic flux through this iron core is passing through this secondary coil. So the magnetic flux of this electromagnet, which is passing through this secondary coil now, that magnetic flux is changing in direction and magnitude periodically. So the magnetic flux which is passing through the secondary coil is changing. So due to that changing magnetic flux, the EMF is induced in the secondary coil. And that magnetic flux, it's decreasing, increasing, decreasing, increasing, plus its direction is also changing. Sometimes the magnetic flux is flowing this anti-clockwise, sometimes the magnetic flux is flowing clockwise. Due to that changing magnetic flux, the EMF is induced in the secondary coil. So that is their 3 marks question. So he says, okay, and what my student wrote, there is an alternating current through the primary coil. It produces an alternating magnetic field. The iron core links this magnetic field with the secondary coil. The rate of the change of the magnetic flux induces EMF and current in the secondary coil. So let me show you the answer. Alternating changing current in the primary coil, alternating changing magnetic flux in the core in the secondary coil, voltage EMF induced in the secondary coil. These are the 3 marks. And I hope you understand. She has written this answer. You also remember my answer. And you can write by looking at the marking scheme. Look at the marking again. And you can write a good answer. Okay. He said there are 60 turns on the secondary coil. There were 750 turns on the primary coil. There are 60 turns on the secondary coil. Calculate the maximum value of the voltage across the secondary coil. Okay. So you remember the NS divided by the NP is equal to the VS by the VP, number of turns in the secondary divided by number of turns in the primary is equal to the voltage in the secondary divided by the voltage in the primary. So there are 60 turns in the secondary, there are 750 turns in the primary. There are 300 volt in the primary. So what is the voltage in the secondary? Just cross multiply here. So 300 multiply 60 divided by 750 and you will get 24 volt. 24 volt, we think is the answer. 24 volt is the answer. Okay, so next question is question number 8. He says the isotope thorium 230. So this is TH thorium 9230 decays by alpha particle or alpha particle emission. Describe the composition of an alpha particle. Alpha particle is like the nucleus of helium. It has 2 protons and 2 neutrons. It's like the nucleus, not the atom of helium. It's like the nucleus of helium. It has two protons and two neutrons. This is alpha particles. It is positively charged. So let's see what she writes. Nucleus of helium, it contains two protons and two neutrons. Question number 8. Question number 8, the marking scheme is showing up on your screen. Okay, so then we have question number 8. It's second part. He says, state the name of the particle that is identical in composition to an alpha particle. The nucleus of the helium is identical to the alpha particle. So nucleus of helium, let's check the marking scheme. Okay. Question number 8 is B part. He says the alpha particle decays by of thorium 230 produces an isotope of radium. Deduce the number of the neutrons in a neutral atom of this isotope of radium. So, when the alpha particle will take place. So let me show you. Yeah, here we go. So for our understanding, we have written this thorium 9230. It gives out an alpha particle, and that is 24, and a radium. So the proton number will be decreased by 2, and the mass number will be decreased by 4. Now, if you from 88, from 2 to 6, if you subtract 88, you will get 138. So the number of neutrons will be 1. From 2 to 6, you subtract 88, you get 138. So number of the neutrons will be 138. Whenever an alpha particle is given out, the daughter nucleus which is formed, its proton number decreases by 2 as compared to the parent atom, and its nucleon number decreases by 4. Its mass number decreases by 4. Mass number minus the proton number, that will give you the number of neutrons. So we just wrote this equation to help us out. So the number of neutrons in the radium will be 138. Then the question is the number of electrons in a neutral atom of this isotope of radium. To be neutral, the number of protons and number of electrons in the radium should be equal. And then that atom will be neutral. So the radium has 88 protons. So electrons should be 88 also. Okay. Then we have, he says, half-life of thorium-230 is 75,000 years. A radioactive sample contains 7.2 expo 16 thorium atoms, and determine the time it takes for the number of the thorium atoms to decrease to 9 expo 15. Okay, so you know how we do this. Normally, we make this grid, and when half-life will be passed. At the start, you have 7.2, and when the half-life will pass. Okay, so at the start, you have this much atoms, so one half-life will pass. So 7.2 expo 16 divided by 2, you get 3.6 expo 16. When another half-life will pass, so 3.6 expo 16 divided by 2, that you will get 1.8 expo 16. And when another half-life will pass, so what will happen? You will have this much. 1.8 expo 16 divided by 2, you will get 9 expo 50. This is that number they are asking. So see how many half-lives have passed. So just count these gaps, 1, 2, and 3. So 3 half-lives. One half-life is 75,000, so multiplied with the 3. So the time passed is 200. I said 75,000. He wrote 2,500. So one more zero here. And so it is 225,000. 225,000 25,000 years, I think. 2.25 Expo 5 years. So I hope you understand. By mistake, she just noted down only 2 zeros. There were 3 zeros. I can show you here. So you can see here. You see here, 75,000. So by mistake, she did not put a zero here. So now I have put it. So this will be the answer. I hope you understand. You see what kind of mistakes you can make in a paper. If there is written 75,000, you might write 7,500 only. So it's the D part G. When it decays, thorium-230 also emits gamma radiation. Figure 8.1 shows a narrow beam of gamma radiation passing into an electric field. On the figure 8.1, sketch the path of the gamma radiation in electric field. You know the gamma radiation is neutral, so the electric field has no effect on it. Magnetic field has no effect on it. So it will go undeflected. It will continue moving in the same direction without any kind of deviation from its path, because the gamma radiation is neutral. Now we have figure 8.2 shows the electric field replaced by a magnetic field that is directed into the page, the beam of gamma rays. On the figure 8.2, sketch the path of the gamma radiation in the magnetic field. You see, the gamma radiation has no effect of the magnetic, so they will go undeflected. So they will go undeflected. Let's check the marking scheme. So our answers are good. There's no problem. So here we have question number 5 coming on your screen. The question number 9, sorry. The Earth has a radius of 6.4 expo 6 meter and rotates on its axis once in every 24 hours. A part is figure 9.1 shows that as the Earth rotates, objects on the surface of the Earth moves in a circular path around the axis of rotation. Okay. Right. Calculate the speed of an object that at the equator as it moves in a circular path around the axis of the rotation. This is 2 pi r divided by time, 2 pi r. The radius of the Earth at the equator is 6.4 expo 6 meter. So the formula is 2 pi r divided by time. So very easy. Easy. So you will have 2 pi r divided by time. So 2 and pi, and the radius is 6.4 expo 6 meter. The time is 24 hours, and in 24 hours, you will have, you want to convert this into seconds. So you multiply it with the 60, and 60 means you multiply it with 3600, because in 1 hour there are 3600 seconds. So your answer will be 465, which is 470 meter per second. 470 meter per second is the right answer, sir. Then he says, explain why the speed around the axis of rotation of an object on the Earth decreases as the distance of the object from the equator increases. If you will go away from the equator, your 2 pi r will become less, and the time to complete that cycle will still be the same. For example, when you will move away from the equator, so the radius of the Earth there will be, the radius of that orbit will be less, but that cycle will be completed still in 24 hours. So less distance covered in the same time, the speed will become less. I hope you understand. The circumference of the orbit decreases as the distance of the object from the equator increases, but the orbital period remains the constant. Still, the orbital period in which that object will complete one cycle around the axis of the Earth will still be 24 hours. So that's why the orbital speed of that object will be less. Okay, so circumference or the, okay, so, okay. So now we are moving to the, well, this is question number 9 and it's B part. The Earth moves around the sun because a force acts on the Earth. State what provides this force. You know, the sun is very massive. The Earth is also has mass. So they both have gravitational attraction. So that gravitational attraction of the sun and the Earth with each other. So the gravitational attraction due to the sun provides this centripetal force. So gravitational attraction field due to the sun. Okay. Question number 9B, second part, he says the orbit of the Earth around the sun is an ellipse. Describe what happens to the magnitude of the force that acts on the Earth as it moves in this elliptical orbit. Okay. So because in the elliptical, you know, your distance from the sun do not remain the same throughout your uh, orbit. So sometimes their distance is larger, sometimes the distance from the sun of the Earth becomes less, sometimes it's larger because you are not moving in a circle. You are moving in an elliptical path. So what will happen? When you are near the sun, that force will be larger, obviously. And when you are away from the sun, relatively aware, relatively your distance from the sun is more and in your orbit. So what will happen? That force will decrease. The magnitude of this force increases and decreases when the Earth is moving towards nearest to the sun. The force is maximum. When it is going away from the sun, the force decreases. Okay. So it depends upon the distance of the Earth from the sun because the orbit is elliptical. So sometimes the distance between the sun and the Earth is less, sometimes it is more. When the distance between the sun and the Earth is less, the force on the Earth of the sun, gravity, is more. And when it's a little away, it becomes a little less. So increases and decreases or fluctuate or varies or not constant, decreases when moving away from the sun or increases when moving towards the sun. Okay. Explain why the Earth travels the slowest when it is at its furthest distance from the sun. As you know that the Earth comes near the sun, it has the maximum kinetic energy. And when it moves away from the sun, its kinetic energy converts into the gravitational potential energy. And near the sun, the kinetic energy is maximum. When you are at farthest from the sun, your gravitational potential energy is maximum. So during this, what happens when you are going away from the sun, your kinetic energy converts into the gravitational potential energy. But when you're coming near the sun, your gravitational potential energy converts into the kinetic energy. Law of conservation of energy is observed. Though energy is converting from the kinetic to the gravitational potential energy back. And that's why the energy is changing. So at greatest distance from the sun, the gravitational potential energy is maximum and kinetic energy, and hence the speed is minimum. Yes. So at greater distance, the gravitational potential energy is the greatest, hence the kinetic energy is smallest, and so the speed is the smallest. This is the what the marking scheme is saying. So I think the paper is over. So this was question number 3. So in this video, we have provided you with the solution of this paper. And my dear students, I hope that this video will be helpful to you. If you find this video helpful and this makes your life little easier, please share the link of this video with your class fellows, with your junior students, with your senior students, with your teachers. You see, when you share the link of this video on your WhatsApp, on your Instagram, on your TikTok, on your Facebook, on your LinkedIn, this helps me to promote my channel and it supports my work. So if you will continue doing this, this will be very helpful for me. So also like this video, also subscribe my channel. Your support is very, very important. At the last, I can tell you in this video, the marking scheme and the paper which I have used, they are the property of the Cambridge Assessment International Education. That paper and that marking scheme has been created by the Cambridge Assessment International Education. That is their property. I have simply downloaded these papers and these marking schemes from their website. So these are the intellectual property of the Cambridge, not mine. The solution was written by one of my very good student in O3, Hajra. Thanks to her. And the basic purpose of using the solution written by a student is to show you that even a very capable student can make a little bit mistakes. So I just wanted to show you how the mistakes. So thank you. How a very capable student can also make the mistakes. So everyone, thank you very much for watching this video. Have a good day. God bless you all.